So today we'll start with stacks and queues. So what are stacks? What are stacks? Stacks is last in, first out, or first in, last out. And what are queues? First in, first out, or last in, last out. Fine. So initially we will be discussing about stacks. We already know how does it look like. That if you put an element here, like for example if you are putting A, then B can come over A, then C, then D, and then if you take out, then D will come out. Fine. That's very easy. What are the applications of stack? Recursion. And applications includes number 1, recursion, infix, postfix, and prefix. What else? DFS and BFS. See, even if you are doing DFS, that means indirectly we are doing recursion only. What else? Towers of Hanoi is recursion. Anything else? Balancing parenthesis already done, but still balanced parenthesis. And any other applications of stacks? Use index text editors and browsers, printer daemon. What is printer daemon? See, when you give multiple commands for printing, all the files are stored inside the printer buffer, and that printer buffer itself is kind of a stack. Okay, and so anyways you are totally familiar with the stacks and what are the applications of stacks. Now there can be different implementations of stack. You can use arrays or you can use linked list. So stacks, we can use arrays or we can use linked list. That means what are the problems with this simple stacks, and then we'll discuss about the circular stacks. Fine. Now in case of arrays, we can use an array to implement a stack. Assuming that name of this is the array, or name of the array is stack, it will be having some index locations. For example, index location 0, 1, 2, 3, 4 and 5. Now there is something called as top of the stack. Top of stack, initially here it is storing 0. Now there are two implementations of top of stack. Either top of stack can point to the next location where the data will come, or it will point to the top location where the current data is. For example, let us suppose here in top of stack we are storing 0, that means it is going to point to the location where the next data item will come. Okay. If I am going to make top of stack is equal to -1, that means it is pointing to the location where the current data item is, or top of the stack is. Now let us say I want to insert 5. If I insert 5, then top of the stack value will become 1, and top of stack will now point to this location. If I insert 6, then top of stack value will become 2, and top of stack will point to this location. If I insert 7, then top of stack value will become 3, and that means top of stack is pointing to this location. Okay, this is not circular stacks, that is circular queues. Okay, anyways. So next is, if I insert an element 8, so top of stack will contain 4, and top of stack will point to this location. Fit and fine. Now if I pop an element, in that case, first of all we are going to decrement the value of top of stack. So we are going to decrement it to 3, and then we are going to pop this value. Then we'll be again, if you want to do do the pop operation, then first of all decrement the value of top of stack and then pop this item. This is how we are going to implement the stack. So for this we are going to use array as a data structure. So we can say integer stack with assuming that n index locations. I can define n, I can say hash define n as 7, 5, 10 or whatever you want to say. Let us say I am implementing hash define n as 5. So anytime I want to represent the maximum capacity of the stack, that means that is n, which is representing 5. So here the maximum capacity is 6, but here I am using maximum capacity is 5. If you want to do push operation, push means you are inserting something inside the stack. For that case you have to give that item. So I can say integer item that you want to push, and then you have to see if the stack is already full or not. For that we are going to use something called as top of stack. So I'm going to take integer top of stack is equal to 0, correct? Now tell me, if I write sirf integer, only integer top of stack, what is the default value of that? That if it is a global variable, if top of stack is a global variable, what is the default value of a global variable? 0. Any global variable default value is 0. And what is a auto variable? Auto variable. See, we can say some variable is a global variable, we can have a static variable, or we can have auto variable, or we can have register variable, okay, or external and intern, okay. But anyways, for static variable default value is 0, for global variable default value is 0, for auto variable what is the default value? That is the garbage value is the default value for auto variable. If I make push integer item, so first of all you have to check what is the value of top of stack. So you are going to say if top of stack is equals n, then you can say printf stack overflow. That means all the items are full. If this entire stack is full, then I'm going to say stack overflow, because if till 4th everything is full, then at the 5th location, when top stack will point to the 5th location, that means all the items are there into the stack. And else you are going to increment the value, you are going to put the item at that location, you are going to say stack of top of stack is equal to item, and then you can do top of stack plus plus. Fine. Now here you can use some return types just to show whether the operation was successful or not. I can say if the operation was not successful, then I can just return 0, or I can return 1 if the operation was successful. Then the return type will be integer. Now this is totally depending on your implementation, whether you want to return 0 or you want to return 1. Totally depends on your implementations. Fine. Now this is simple implementation of a push function. Now we have to see a simple implementation of pop function. So I'm going to say integer pop, and it is not taking any input arguments. So what is a pop function? That means you want to take something out of the stack. Now if, let us say, when you cannot pop when stack is empty. So if top of stack is equal to 0, then I can say printf stack underflow. I can say printf stack underflow. Else I have to find out that what is the item. For that I have to decrement top of stack. So again I'm going to say integer item. Let us say I can write it here. I can say integer item is equal to stack of minus minus top of stack. That means decrement the value of top of stack, get the data at that location and store that data into the item. And I can say return item. Okay, and because it is a return integer, so we are returning int. But here if you want to say that operation was not successful, that means if the condition is stack under full, again we have to return some value. So you can use an imaginary value, assume it is -1. As it is -1 just to say that operation was not successful and stack under full. So I am just returning -1 to say the operation was not successful, otherwise I am just going to return that particular item from this stack.
So what if we have an element which is having value as a -1?
See, I am saying that this is implementation, right? Simple implementation. When I am saying return -1, I am assuming that all the items are greater than -1. Okay, this is just a I'm using for representation purposes. If you return -1, then the operation was not successful. Otherwise, you can use any other number. That is your complete personal choice. So this is a very, very simple implementation of stack, and there is nothing special about stacks a part of this, right? The only thing is that is special is about previous year questions and the applications of stack. Now let us see some of the previous year questions based on this. You can write it down if you like. Try the question number 3.1. Question number 3.1, very easy. D, B, B or D? How many people are saying B? B for ball. And D? D1, B. All of you are saying B, na? Very easy question, nothing difficult, right? Try question number 3.2. How many are saying option number B? Anyone needs explanation for this? No? Okay, good. Yes, you need explanations, fine. See, it is saying that which of the following permutation can be obtained in output using a stack, assuming that input sequence is 1, 2, 3, 4, 5 in that order. Now see, permutation means that what are the possible outputs or possible combinations that you can have, right? For example, here in this particular case, what you can do is, let us say you want to put 1, 2, 3, 4, 5. So if this is a stack, then initially you can put 1 because order is 1, 2, 3, 4, 5. Then you can put 2, then you can put 3, then you can put 4, and then you can put 5. And when you pop them out, then first 5 will be popped out, so output will be 5. The next popping value will be 4. Next we can have 3, next we can have 2, and next we can have 1. So it is 5, 4, 3, 2 and 1. This is one combination. Is there any other combination possible? Let us try. If this is the stack, initially I can insert 1, then I can insert 2, then I can pop 2, so output can be 2, then I can pop 1, output can be 1, then I can insert 3, I can insert 4, I can insert 5, then I can pop 5, I can pop 4, and I can pop 3. So this can be output combination. Now they are saying if this kind of combinations can be there, out of these 4 combination, which of the permutation can be obtained? Which of the permutations can be obtained? So let us look at the first option. First option is saying that we have 3, 4, 5, 1 and 2. That means initially we are inserting 1 because we have to insert in this particular order. Then we are inserting 2, then we are inserting 3. Now just because we need 3 as output, the first output is 3, so we have to pop 3 out of the stack. So if you pop 3 out of the stack, we can get 3. Next is 4, so you can insert 4 here, then you can pop 4 out of the stack, so we can get 4. Next is 5, so you can insert 5 into the stack and you can pop 5, so 3, 4, 5 can be there. Now again 1 and 2 is already there, so next value which can be popped out is only 2, so we can pop 2 and then we can pop 1. So here 3, 4, 5 is correct, that is perfectly fine, but here this order is not correct, that is why option number 1 is not correct. Okay, let me explain properly. Now second option number B. So in case of option number B, you are inserting 1, then you are inserting 2, then you are inserting 3, then you can pop 3, so this can be obtained, then you can insert 4, you can pop 4, so this can be obtained, then you can insert 5, so you can pop 5, so this can be obtained, and then 2 and 1, they can also be obtained. So this entire option number B can be obtained. But what's the problem with option number C and D? In case of option number C, I can insert 1, I can pop 1, so this can be obtained. Then I can insert 2, I can insert 3, I can insert 4, I can insert 5, then only 5 can be popped out. So this can be obtained. But after 5, the only thing that can be popped out is 4. But here because we are getting 2, so this is not a correct answer. Next is option number D. So it is saying 5, 4, 3, 1, 2. Now we already know this 1 and 2 cannot be the correct answer. So it is 5, 4, 3 and 2, 1. So that can be the correct answer for this problem. So answer is option number B. Okay. 3.22. Question number 3.22. Okay. See, the program execution will start from the main function. It says integer b with 20. That means we have an array b which is having 20 index locations. Index locations are 0, 1, 2, 3, 4, 5, 6, 7, 8 up to so on 19. Correct? Now we have taken an pointer a, star a. Why I have taken pointer a? Because here in this line they are saying a is equal to b. So if a is a pointer, that means a is also pointing to this array. Fit and fine. Next they are saying stack top is equal to -1. Stack top is a variable, so it is stk top, which is storing -1 and it is a global variable. Now they are calling this function. They are calling this function, and inside this function they are passing -1 and 10. Now see, make sure that when you are using the case 2, case number 0 means we are inserting some values. It means we are inserting, or you can say pushing some values, right? And when we are using the default case, that means we are popping some values. And here when we are using case -1, that means we are doing something, maybe defining the size of the stack or something, maybe something we are doing, right? Then we first pass stack function -1, 10. So this opcode is -1 and the value is now 10. And we have a static integer size. So this is the size variable, which is a static variable, which is storing 0. And this is a local variable to this function. This is a global variable, this one is a global variable, and this one is a local variable. So here again we have a stk top, stack top as a variable which is storing 0. Now when we do switch opcode means this value -1. So this case -1 will be executed, which is saying size is equal to value, and value that we passed is 10. Therefore the value of size will become 10. And then this will get out of the switch function, and we are going to return -1. That's okay because there is no use of -1 here. Next function is stack function, and we are passing 0 and 5. Thank you. We are passing 0 and 5. That means to this operation code we are passing 0, and to this value we are passing 5. So when this operation code is 0, see now this line will not be executed again because it is a static variable, so this will not be executed again. So when we passed operation code as 0, that means we are making this case, and value is 5. So it is going to check what is the value of stack top. The size is 10 and the value of stack top is 0. So this condition is true. We are going to make a of stack top plus plus is equal to value. A of a means this array. So stack top the value is 0. So in this index location 0 we are going to store 5 here. So 5 will be stored here. Okay, and the value of stack top will become 1. Remember we are not affecting this stack top, we are affecting this local variable. And then we are going to make break. We are going to execute break, so we'll come out of this loop and we'll return -1, right? And then next is stack function 0, 10. So we are going to pass 0 and 10. So 0 will be here and 10 will be here. So 0 means again we are executing case number 0. So stack top value is 1. 1 is less than 10 and yeah, so 1 is less than 10,
It becomes 0 now because that variable is not static.
which will become 0.
Static.
It will not become 0 na, because it is a variable, is a static variable. So stack top values.
Stack top is also static.
Huh. See, we have two stack tops. Here, this is a global variable and this is a static variable, right? So again, we are going to execute this code, and a of 1 is, we are going to put this value 10 here, and then we are going to make this value as 2, and we are going to break. So again, it is going to return -1. Then we are at the printf statement. So here we are passing stack function 1, 0. 1 means this is the default case. So we are going to pass 1 here, and we are going to pass 0 here. 1 means we are going to pop the value. So it is popping the value from the stack top. Stack top is containing 2. So minus of 2 is 1. So this will return that value. So it is going to return 10. So 10 will be returned here. And in the next case, we are again passing 1, 0. That means again we are popping out. So popping this value, which is 5. So 5 will be returned here. So it is 10 plus 5, which is equal to 15. So answer is 15. It is going to print 15.
So
Correct?
while in the stack function returning -1 will not cause any problem.
It's not. We are not caching that. We are not catching it, but there's no problem with it. Okay. So answer to this question is 15. Now take the question number 3.9.
क्वेश्चन जो होते हैं जिसमें खुद से डिराइव करना होता है, लाइक क्वेश्चंस होते हैं जिसमें पहला थ्योरी होता है, दूसरा होता है जिसमें कि ऑप्शन को पुट करके आप आंसर निकालते हैं, लेकिन जो डेरिवेशन वाला होता है उसमें नहीं समझ में आता किसी भी सब्जेक्ट में क्या अप्रोच कैसे करें.
Generally, again I'm saying it is because of practice. See, what happens is now when you are a teacher, when I was preparing for GATE examination, till the time when I was a student, my progress was limited to a certain level, because student can only think about a certain level. So you can learn more if you teach more. So when I was preparing for GATE, I was teaching the same thing. What I used to do is I used to prepare the content, the particular chapter for GATE, and then I used to teach the same thing to the students. Okay, so when you tend to teach things, then you tend to learn how these things are developed, because when you have to explain someone, then you are just not going to explain that this is the answer. You have to explain how we came to that particular point, or how this thing is derived, or how this thing is created. So then you tend to learn more about solving this kind of problems. So unless you practice or unless you teach, your potential is limited to certain level. For example, till the time when I was not teaching, so I was getting some average marks for GATE. So just because I started teaching, I learned something from a new student, or I have to explain these things to students, the concept should be right. Even if I get the answer correctly, but its concept is not wrong, then someone is going to catch me and he is going to say he don't know anything, right? So the only thing for practice is about that you have to get the correct concept, you have to derive that concept so that students will be able to understand. And that is how I can say there is a practice for solving this kind of problems. So you cannot just, right now if you see 5 or 10 questions, you may not be able to derive it. But when you teach or when you practice more, then you will be able to derive these kind of questions very easily. You can teach your fellow students, classmates. Okay. So how many of you are getting the correct answer? You need more time to solve this problem? Answer pata hai, but you're not getting the answer. Huh? Okay. See, they are saying let S be a stack of size n greater than equal to 1. That means there is a stack whose size is greater than 1. Assume this is a stack, the size is greater than 1. Now they are saying starting with empty stack, we push the first n natural numbers into the stack. We are pushing some n natural numbers into the stack. Now they are saying then we are performing n pop operation, we are performing n push operations, then we are performing n pop operation. Assuming that push and pop operation takes x seconds each and y second ellipse between the end of one such stack operation. That means when you are going to push, it is going to take x second. When you are going to pop, it is going to take x second. But between these two push and pop operation, it is going to take y seconds. And the start of the next operation, for m greater than 1, define the stack life of m is the time elapsed between the end of push to the start of the pop operation that removes m from the stack. I mean, for any particular element, what is the stack life? That is the time taken between the push and the pop of that particular item, that is called as a lifetime of that particular item. Now, average stack lifetime life of an element of this stack is, on an average, if you are going to put n natural numbers, then on an average, what is the average stack lifetime of an element? Okay. Now look at this. If you know about average lifetime, so what the question is saying that if this is the stack, and let us suppose you are pushing 1 inside the stack. Just to push 1, it is going to take x seconds. Then we have to wait for y seconds so that we can perform the next operation. And then we have to take x second to pop this item out of the stack. This is what they are telling you. Now this is case when we have only one number. Let us suppose we have two natural numbers, that is 1 and 2. So what you can do, this is the stack. Okay, we have 1, 2, two items inside the stack. So we have to put 1 inside the stack. Pushing of 1 takes x second. Then we have to wait y seconds to perform next push operation. Okay, so 1 is still there in the stacks for x plus y seconds. Then we have to take x seconds, x plus y, then we have to take x second to push 2. So 2 will come here. Till this time, 1 is for x plus y plus x second. 1 has waited this much time and 2 is inside the stack. Now we have to wait for y seconds. So 2 will wait inside the stack for y seconds. Okay, see here, if you are going to say how much time 1 is going to wait, that is 1 is going to wait for y seconds only. How much time 2 is going to wait, that is 2 is going to wait for y seconds. Okay, there are two ways. Either you can assume that x time is going to take to push it, then y time is going to take for this 2 to be then inside the stack, right? And that y time here, it will also wait for, x1 will also wait for that particular y time. And then it will take x time to pop 2 out of the stack, so that x time will also be added for 1. And then we have to wait for y seconds because 2 is out of the stack. And then we have to push again, we have to pop 1 out of the stack, that is again going to take x seconds. Now roughly see here, two things are there. Either you can assume that this pushing and popping time will also be added, or you can neglect this pushing and popping time. You have to read the question carefully for this. See, define the stack life of m is a time elapsed from end of push operation to the start of pop operation. This word, which is what they are saying, end of push and start of pop, that is important. Because here, if you see the first case, the total time taken for 1 to go in and come out is x plus y plus x. But if I say stack lifetime of 1, the lifetime is only y second, because the end of this operation and start of this operation. So the stack life of this item is only y seconds. In the same way, if I say what is the stack lifetime of this item 2, that is y seconds, and what is the stack lifetime of 1, we are not going to use this, that will be equal to 2x plus 3y, correct? 2x plus 3y. In the same way, when we have to push three items inside the stack, 3 items, assuming that this is a stack, we have to push 1, okay? So x time will take to push 1, then y time we have to wait, then it is going to take x time to push 2, okay? Then y time, this 1 is going to wait and 2 is going to wait for y time. Then we have to push 3, that is going to, for that 2 is going to wait for x time, and it is also going to wait for x time. Then for y time we have to wait, it also has to wait for y time, and this also has to wait for y time. Then this 3 will be popped out. Okay, when it will be popping out, it has to wait for x time, it has to wait for x time, and again we have to wait for y time to perform the next operation, and then this 2 will be popped out. For this it has to wait for x time, and it also has to wait for x time it will take, and it has to wait for x time, and then we have to wait for y time to perform the next operation, and then this 1 will be popped out, that will take x time. So in total this x and this x will not be calculated. Why? Because it is end of push operation and start of pop operation. So how much time this 1 will be waiting, how much time it will take for this one into the stack, that is x plus x plus x plus x, that is 4x plus 1, 2, 3, 4, 5, which is 4x plus 5y, right? Is it 3x or 4x? 4x. For 2, how much time it is going to wait? That is 1, 2, 3, 3y plus 2x, because this is not calculated, 3y plus 2x. How much time it is going to wait? That is y. Okay. Now when we have to find average, they are saying the average stack. That means we have to take for all the elements and we have to divide it by n. Now for example, here if we had 3 items, then for these 3 items, this is y seconds plus this is 3y plus 2x setting seconds plus this is 5y plus 4x seconds divided by 3, because total are 3 items. These are total 3 items. In the same way here we had only 2 items. So total time taken was 2x plus 3y plus y. This is for the item 1 and this is for the item 2, and divided by 2. And here the time was for only one element, correct? So this is for 2 items. So the total number is 2x plus 4y divided by 2. This is for 3 items. The total time taken is y plus 3y is 4y, 4y plus 5y is 9y plus 6x divided by 3. In the same way you can find for other items also, correct? Is it correct? Now you have to find the pattern. I mean, we have taken 3 items. If let us suppose we have 5 items, 6 items, or we have n items, what is the pattern that we are following? For one item we are getting 2x plus 4y divided by 2. For 2 items we are getting, for one item we are getting y divided by 1. For 2 items we are getting 2x plus 4y divided by 2. For 3 items we are getting 9y plus 6x divided by 3. So this is going one item, this is the only stack lifetime, y. For one item it is y, for 2 items it is 2x plus 4y. Is it correct now? Right? So this is going to be x plus 2y. This is going to be 2x plus 3y. Okay, so what is the pattern? Pattern is going to be, for one item it is y time, for 2 item it is x plus 2y, for 3 item it is 2x plus 3y, for 4 item it is going to be 3x plus 4y. Okay, and then for n items it is going to be n minus 1 into x plus ny, which is going to be nx plus ny minus x, which is, you can take n as common, so it is x plus y minus x. So answer is option number C. Got it? Okay, so here you have to make sure that you don't miss the words end of push and start of pop, because these small words creates a huge difference in solving the questions. Cool? Okay. Try question number 3.15. This is a very tricky question 3.15. f of s is the stack for all stack s and integer I. I is the value that you want to insert and s is representing the stack.
If it doesn't stop, then answer will be 3.
Hmm?
If it doesn't stop, then answer will be 3.
Answer will be 3. Yes. So answer is option number C. Let me explain it. This question was very tricky. Okay. So it says a function f defined on stack of integers satisfy the following properties. First is f of phi is equal to 0. That means when the stack is empty. The initial value of function f is 0. When we are going to push some items, we are going to call f of push s comma I, where s is representing the stack and I is the item that you want to push, which is equal to maximum from fs that we have already calculated, that the previous value, comma 0 plus I. I is the next value that you want to insert for all stack s and the integer I. If a stack s contains these integer values, which is 2, minus 3, 2, minus 1, 2, in order from bottom to top, that means the stack is currently containing, it is containing 2, minus 3, 2, minus 1 and 2. Now what is the value of fs? That means after containing these values, after the function stack is containing these values, what is the current value of fs? This is what they are asking. Okay. Now remember here, when they are saying I is presenting the element to be pushed, okay, and s is representing the stack. So the initial value of the stack is, initial value of f is 0. That means initial value of, when we start, the initial value is 0 when the stack is empty. So this is when you're saying f of phi is equal to 0 initially when stack is empty, okay, this is representing when stack is empty. Now we have to find the new value which is represented by this function. So you can say f of new, the new value can be we can use this formula to find the new values, which is using the old value, or you can say the previous value, comma 0 and the new value. Okay. So initially the first item that they inserted into the stack, that is item number 2. So for this item number 2, the initial value f of new will be maximum between f of previous value, comma 0 plus I, the new value which is 2 that we wanted to add. So previous value was 0. So it is maximum from 0, comma 0 plus 2, which is equal to 2.
So I is index.
I for all the stack and the integers I. These are the integers that you want to add. I is representing the value that you wanted to add. So here the value of I is 2. Okay. So the new value that we found for f of new is 2. Then we have to insert the next item, which is minus 3. So this value will be f of new for s is going to be maximum from the previous known value, which is 2, comma 0 plus the next value is minus 3. So then we are going to get the answer as 2 minus 3, which is equal to minus 1. And the next value again we have to find. So next value that we are inserting is 2. So it will be f of new for s is going to be maximum from minus 1, comma 0 plus 2, because that next value that we inserted is 2. So which is going to be 0 plus 2, which is equal to 2. Then the next value that we have to insert is minus 1. So f of new of s will become maximum from the previous known value, which is 2, comma 0 plus of minus 1, which is equal to 2 minus 1, that is equal to 1. So that is the fs value will be 1. And the next value that we want to insert is 2. So that it will be f of new will become maximum from 1, comma 0 plus 2, which is equal to 1 plus 2, which is equal to 3. So the correct answer to this problem is option number C, which is presented by 3. Okay. Any doubts? Anyone? No doubts? Oh, smart. Okay, fine. So solve the question number 3.16. Is it visible? 3.16. They are saying an implementation of a queue using two stacks S1 and S2 is given below. Okay. In general, you know how queues are implemented using stacks?
Yes.
Yes? How many of you know how we can implement a queue using stack? Okay, 3 people don't know. Fine. See, the difference between queue and stack is the order in which items are going to be dequeued or popped out. For example, here in case of queue, if we insert the items in the sequence A, B, C, D, then initially A will be there, then B will be there, C will be there, and D will be there. If we take A out of the queue, I mean if we dequeue, and queue there are two operations, one is enqueue and second operation is dequeue. Dequeue means taking one item out of the queue. So if we dequeue one item, so A will come out of the queue. So next item that can be dequeued is only B. Next item that can be dequeued is only C. But in case of stack, let us suppose this is a stack. Initially the first item that we are pushing is A, next item is B, next item is C, and the next item is D. So if this D is coming out of the stack, if we pop out, then D will come out of the stack, then C will come out of the stack, then B will come out of the stack, and then A will come out of the stack. So if we push, then we can push in the order A, B, C, D. But if we pop, then the popped order will be D, C, B, A. So there is a basic difference between the stack and queue operations. But if you want to implement queue using stack, when I am saying queue using stack, how we can do it? We have to use two stacks like this. Two stacks. Assuming that we want to put A, B, C, D inside the stack. So what we are going to do is we are going to push these items in the first stack. So first item that will be pushed is A, then B, then C, and then D. But if you pop an item from the stack, that will be in the order D, C, D, A. Therefore, what we have to do is we have to take one item out of this and we have to put that item onto the next stack. So the next stack will be containing D, then C, then B, and then A, and then we can pop it out. So it will again represent this particular order, which is this order which is represented by this queue. So we can implement a queue using two stacks. So we have to push items here, and when we have to enqueue, then we have to push items onto the stack. And when we have to dequeue means we have to pop item up from this stack and push those items inside this stack and pop it from this stack. So we need at least two stacks. Now this is giving similar kind of implementations. It is saying that we have two stacks S1 and S2. That means these are two stacks. This is the stack S1 and this is representing the stack S2. Now when we are pushing some item, the first item that we are pushing is S1. So when we are pushing some items, that item will be pushed inside the stack S1. That item can be anything. That item can be A, that can be B, that can be C, that can be D, or any other item. So if you are pushing, then A can be pushed here, B can be pushed here, C can be pushed here, and D can be pushed here. And when we have to represent the dequeue operation, this is representing dequeue operation and this is representing the enqueue operation. When we have to do the dequeue means we have to check whether this stack is empty or not. It is saying if this stack is empty, then if this stack is also empty, if both the stacks are empty, that means we don't have any item to pop. We don't have any item to pop, right? But if this stack is not empty, like for example this stack is not empty but this stack is empty, then until this stack becomes empty, then it is saying until S1 is not empty, pop the item from S1 and push that item to S2. Until this is not empty, pop item from here and push that item here. Okay. And when this loop ends, you have to pop that item from S2. Now they are asking if we have to perform an insert operation. There are n insert operation and there are m delete operation. There are m delete operation where the value of n can be less than or equal to n. That means it can happen that you want to insert 10 items but you want to delete only 5 items. It can happen that you want to insert 10 items but you want to delete only 7 items, or it can happen that you want to insert 10 items and you want to delete 10 items, all these items. So then let x be the number of push operations and y be the number of pop operations that you are going to perform. Then they are asking which of the following is true about m and n. That means what should be the relation between x and y as compared to m and n. That is, what is the number of push operations according to the numbers and what is the number of pop operations according to the number. Now when they are giving these options, this is a bit tricky just because they are asking what is the worst case scenario and what is the best case scenario. Let me explain to why they are asking this. Look at the options. For x, they are giving a range. It is saying the minimum value of x is m plus n and maximum value can be 2n, and minimum value of y can be 2m and maximum value can be n plus m. In the same way here, for every option they are giving a range that x can be greater than this but less than this, y can be greater than this but less than this. That means they are giving range for every option here. So you can say either they are asking what is the minimum value of x or what is the maximum value of x, what is the minimum value of y or what is the maximum value of y. Okay. Now make sure that when you have to find minimum value and maximum value, that means you have to see what is the best case scenario and what is the worst case scenario. Okay, what is the best case scenario and what is the worst case scenario? Let us say you want to insert n items, and you want to, that is nq n items, and you want to dq m items, dq. So what can be the best case and what can be the worst case? We have to find what is the best case scenario, that is when the minimum number of push can be there and minimum number of pop can be there. Okay, and the worst case when maximum number of push can be there or maximum number of pops can be there. Now can you tell me when can we get the minimum push and minimum pop? When there is only one item. Are you sure? For every item there is one pop. Single pop. That means you wanted to insert one item and delete one item. Okay. Huh?
Sir, जैसे ये कह रहे हैं, we have to insert an item and we have to delete one item.
Yes.
इसलिए तो बहुत ज़्यादा overhead हो जाएगा, सारी pop करने पड़ेगी तब.
Correct. Correct.
वो worst case.
See, worst case, that is not the worst case. See, they are saying, see, in the question they are saying, the value of m can be less than n, but value of m can be anything. See, m can be 1, m can be 2, m can be 3, m can be 4, any value of m can be there. But when we are saying the best case or worst case, never consider that the value of m is 1 for this particular case, because they are just giving that m is less than n, but they are not saying that value of m is 1. Okay, we have to generalize it. If you are saying that value of m is 1, that is for a specific case only. That is just for a specific case. They are asking that it should be valid for every case. It should be valid for every case. Now let us see what are the cases that can be there, and accordingly we can find what is the number of push is required and what is the number of pops are required. This is the stack S1 and this is the stack S2. Now you want to push n items, okay, and then in the last you want to pop m items. What are the options? Number 1, push n1 item here, then n2 item, then n3 item, then n4 up to so on. This is the nth item, last item. Okay. So how many pushes are required? That will be.
I mean, they are using x and y for these operations and m and n for the FTQ.
M and n. See, they are saying n inserts an empty. See, I'm just telling what are the options can be there. Then I'll explain the question. Okay. So initially, generally I'm just telling what are the options can be there. Now, if you want to insert n items here, and then for these n items, a total of n push operations are required, right? Then you have to pop these n items to push it here. So for this you need n pop operations, and then you have to insert all these n items here. For this you need n push operations. Okay, so these items will be n minus 1 up to so on n1. Okay, now from these items we have to pop m items. For this you need m pop operations. So in total, how many pop operations are there and how many push operations are there? Total of n push operations here plus n pop operations here plus n push operations here plus m pop operations. This is the first case. Okay, so that is in total we had to push 3n push operations and 1m pop operation.
2n push operation and n plus
Yes. 2n push operation, that is 2n push operation, and then n plus m pop operation. N plus m pop operation, right? And what can be the next scenario? The scenario can be like this. If this is the stack S2 and this is the stack S1, okay? Then you have to push all these items here. Fine. You have to push all the n items here, that is you need n push operations. Then you have to pop m items, that is m pop operations, put those m items here, and then you have to pop these m items. Okay, so in total we popped total of m items, right? Correct? But is it a correct scenario? See, that means we are not representing a queue. This is representing, but we are not creating a queue for this. Not creating a queue. Why we are not creating a queue? Because the last m items we are popping out. So this is not correct. We cannot do it. Correct? So what can be the third scenario? Third scenario can be if I use S1 stack and this is a S2 stack. First of all, I am pushing m push operations. M push operations. Then we are popping these m items. Pop these m items. Push these m items here. Okay. And then push all the other n minus m items here. And pop those m items from here. Pop those m items from here. Do you understand what I have done? See, the example is like if you want to insert 1, 2, 3, 4, 5, 6, 7, 8. Let us suppose the value of m is 1, 2, 3, 4. And this is total the value of n. Now in a queue operation, if you want to pop m items, that means those m items will be 1, 2, 3 and 4. But if we use this scenario, then we can get this particular order. So in this scenario, how many push operations are there? How many pop operations are there? Okay, wait. Listen. This is the stack S1 and this is the stack S2. Okay. I am saying initially I have done m push operations. So total items were n items. So out of these items I pushed n. So total of n minus m items are remaining. Okay. So I push total of m items here. Then I have taken those m items from here. That is, I have taken m pop operations and I pushed those m item here. Okay. And then I can pop those m items from here. Pop m. And all the remaining n minus 1 items I can push it here. So all the remaining n minus 1 items push total remaining n minus 1 items. So I just needed the top m items. So how many push operations are there? This is the m push operation plus this is m pop operation plus this is m push operation plus this is m pop operations plus n minus m push operations. So in total, how many pop operations are there? M pop. So in total of 2m pop operations can be there. Plus how many push operations are there? M push, that is 2m push operations plus n minus m push operations, which is in total how much? That is 4m push minus m plus n. Sorry. So this is 2m pop plus m plus n push operations can be there. Okay. Is it less as compared to the previous value? What was the previous value that we got? The previous value was 2n push plus m plus n
Sorry, 2n push plus m plus n pop.
pop, right? Out of these two values, which one is smaller? See, look at these two push operations. We already know that m is less than or equal to n. Okay, so obviously this value is smaller and this value is bigger. Okay, this is a smaller value, this is a bigger value. And if you see this pop, that is m plus n pop, and this is 2m pop. Out of these two values, which one is smaller? That is, this is the smaller values. Okay, so if I discuss about the pop operations, so in minimum, how many pop operations are required? Minimum, how many pop operations are required? That is 2m pop. And maximum, how many pop operations are required? That is m plus n. Okay, in the same way, how many push operations are required? Minimum, that is m plus n. And how many push operations are required? Maximum is 2n. Okay, so is there any scenario which can be better than this? No, these are the two worst case and the best case scenarios. So look at these two worst case and best case scenarios and compare with the options. It is x is the push and y is the pop. So minimum push operation is n plus m. Option A. We are getting option A as the correct answer for this.
Actually, what I did is like I took a single queue, direct queue implementation,
Okay.
and the other process is by using this program implementation.
Okay.
So just compare the number of operations in both the substitute and the option.
Yes. But then that is just giving you on an average general option, na? But that is not giving you a minimum value and the maximum value. So you need what is the minimum number of push operations are required, what is the maximum number of push operations are required. So in total you can find minimum push, maximum pop, or maximum push, minimum pop. Okay? Good? Now try question number 3.10. That is two stacks that is representing two stacks. Okay, how can you do it? See, if this is an array, within a single array we can implement one stack, or we can also implement two stacks. How? You can use one side to implement the first stack, and you can use the second side to implement the second stack, or you can use a single array to implement 3 stacks, 4 stacks, 5 stacks, whatever number of stacks you want. The only thing that will differ is the stack underflow value for top of stack and the stack overflow value for top of stack. That means, for example, here we are implementing 2 stacks. If we implement 3 stacks, what can be there? If this is the array, then we can consider the first stack to work here, second stack to work here, and third stack to work here. So here we can have top of the stack, here we can have top of the stack, and here we can have top of the stack. So if These index locations are 0, 1, 2 up to so on x. It will be x plus 1 up to so on y. Next will be y plus 1 up to so on z. For the first stack, for this stack number S1, this is stack S2 and this is stack S3. For stack S1, what is the stack overflow condition? When top of stack is x plus 1. What is the stack underflow condition? That is minus 1 or 0. For top of stack this S2, what is the stack underflow condition? X plus 1. And stack overflow condition is y plus 1. For stack S3, stack underflow condition is y plus 1 and overflow is z plus 1. Okay, so doesn't matter whether you have 1 array, 2 array, 3 array, 4 array or any number of arrays. So you can implement more than one stacks using one single array. Okay, so in this question they are saying a single array from size 1 to max size is used to implement 2 stacks. From a single array we are implementing 2 stacks. Now the 2 stacks grow from opposite end to the array. That means one stack is going from here and second stack is going from here. So they are implementing like this, right? They are going from opposite end of the array. Variable top 1 and top 2, where top 1 is less than top 2, obviously, because if this is the index location 0, 1, 2 up to so on, this is n minus 1. So first top of stack will be here and second top of the stack will be here. So top 1, if it is say top of stack 1, this is top of stack 2. So top 1 will be less than top 2. Point to the location of the topmost element in each of the stacks. If the space is used efficiently, the condition for stack full is, what is the condition for stack full? D. Okay.
It will work only for if the size is even.
See, they are asking what is the most efficient. Most efficient. Try to solve this. D. How many of you are saying D? 3 people. Others you can try and solve. Maybe, I don't know the answer. I don't remember the answer. Okay. Yes? D, why? So? Okay. Okay. Vaibhav? Yes. B? Okay. Yes.
इसमें efficiently यूज करने का मतलब ये नहीं कि दोनों stack equal होना चाहिए.
Correct. Correct. देखो, what can happen here? We can implement 2 stacks. Okay. Like for example, this is an array. These are the index locations. 0, 1, 2, 3, 4, 5, 6 up to so on. Let us suppose this is n minus 1. These are the index locations. Fine. Now, if you are implementing 2 stacks, you can assume that this can be the first stack from this direction. For this, we will be having top of stack value, and the second stack can be from this direction. For this, we are going to have a top of stack value. Now, while implementation, there are 2 options. Number 1, you define what is the size of the stack. What is the size of the stack? You are saying if there are total n items, so stack 1 is containing n by 2 items and stack 2 is containing total of n by 2 items. So exactly partitioning is from the exact middle. Partitioning is from the exact middle. But the problem with this is that if let us suppose in the first stack you only inserted 2 items, in the second stack you inserted 10 items, and you want to insert more items. So this in the second stack you inserted total n by 2 items and you need more space. This stack does not need extra space, but this need extra space. Out of n by 2 items, you inserted 2 items and you wasted n by 2 minus 2 items space for the n by 2 minus 2 items. So that is wastage of space. Wastage of space. So next better thing is do not fix the midpoint. So if this is the array, we say the first stack can grow from this direction and second stack can grow from this direction. But midpoint can be anywhere. This can be a midpoint, this can be a midpoint, this can be a midpoint, but midpoint can be anywhere, because if we fix the midpoint, it can happen that one stack is not utilized. We are not utilizing first stack and we are utilizing the second stack. Okay. Now in the first option they are saying top 1 is equal to max size divided by 2 and top 2 is equal to max size divided by 2 plus 1. This cannot be efficient utilization, efficient implementation, because we are fixing the midpoint. Now second is top 1 plus top 2 is equal to max size. Maybe this may be an efficient utilization. Maybe, I don't know. I don't know how they implement it. I'm just saying maybe this is an efficient utilization. In the third option they are saying top 1 is equal to max size divided by 2 and top 2 is equal to max size. Again they are dividing by 2. Okay, they are saying that top 1 should grow from this direction till the max size and top 2 can go from this direction till the max size. So this is not the efficient utilization again. So option number A and D we already eliminated. Now two options are left, option number B and D. We have to check out of these two options, option number B and D, which option is the correct option. Fine. Now imagine this scenario that this is a stack which is containing 1, 2, 3, 4, 5, 6, 7, 8 and 9. This is the stack. And this is the first stack S1 and this is representing the second stack S2. So in the first stack we have items A, B, C and D. In second stack we have items X, Y and Z. So top of stack for S1 is going to be 5 and top of stack for S2 is going to be 6, right? Top stack for S1 is 5, top of stack for S2 is 6. Now if I want to find that in the option number B, they are saying top 1 plus top 2 is equal to max size. The value of top 1 is 5, the value of top 2 is 6. So 5 or 6 plus is going to be 11, which is exceeding the max size. So this may not be a correct implementation because max size is still 9. I started from the index location 1, so max size is still 9, but we are getting a addition as 11. So this cannot be a correct answer. So the only correct implementation is option number D. Okay, only correct implementation is option number D. Fine. Now try the next question.
Sir,
Yes.
sir, this line, if the space is to be used efficiently is not there,
Uh-huh.
then what will be the answer?
See, efficiently that totally depends on implementation. There are multiple implementation, but you have to define what is the goal of that implementation. Here the goal was to use efficiently, but if you want to implement 2 stacks, either you can partition from half, or you can do 30% size to one stack and 70% size to second stack. That totally depends on the goal what you want to have.
So, sir, what will be the answer according to that?
See, that in question they will specify that what is the goal. Okay, they can specify that 2 stacks are implemented from an array with exactly half partition. Okay, then they can give a question. हाँ, what will the correct? Okay, got it?